For this first problem that was on the warm-up, I'm going to go ahead and do that since it is tied into what we're doing today with logarithmic word problems. You need to remember the formula that the amount in account equals the principal times 1 plus the rate divided by number of times compounding raised to the number of times compounding times your time in years. So what you're going to go ahead and do here is plug in your information. It says it currently has a balance of $3,052.49. That's going to be my amount that I have. I do not know the principal, but I do know the rate, number of times compounding, and the years. So the rate, it said, was 4%, so I'm going to put that in as 0.04 over number of times compounding. Since it's monthly, that's happening 12 times in a year, times 5 years on the exponent. So now what I'm going to do is I'm going to go ahead and type this whole thing, 1 plus 0.04 over 12 raised to the 12 times 5 into my calculator. And it gives me 1.221. So I'm just rounding there whenever I say that. So P is getting multiplied by that value. Now what I'll do is I'll divide by that value on both sides to get my answer. So in my calculator, what I'm doing, by the way, is just using the previous answer. I'm not actually typing in 1.221. So I get $2,500 when I round it to the nearest penny. And that's my final answer. Alright, first thing I'm doing on example 1 is I'm going to make the model, and I'm going to use my calculator for that. I'm going to let X be the number of years since 2000. And I'm going to let Y be my population. Now what I'm going to do is create the coordinates 0 years. It was at 5,280 because the year 2000. And then at 8 years, it's at 7,800. Now I'm going to take those coordinates I just came up with from the problem and plug them into stat in my calculator. And I'm going to show that process now. So what I'm going to be doing is hitting the stat key right here. And to go over to calculate and, go ahead and enter on edit. And go ahead and put those coordinates in that I just came up with a moment ago, X and Y, X being list 1, Y being list 2. And now I'll hit stat yet again and calculate. And now I'll do an exponential regression. So I'm going to use this function right here. Y equals 5280 times 1.04, I'll make that 1.05 to the x. Usually you'd want to round further than that, but that's fine on this problem. Now what I'm going to do is actually figure out when this 15,000 is going to be achieved. So putting in 15,000 for my population. First thing I'm going to want to do now is get my base by itself. So I'm going to divide by this 5280 on both sides. And now I'm going to type that in my calculator. When I do that, I'm going to get a decimal, but I'm just going to turn it back into a fraction and leave it as 125 over 44. Equals 1.05 to the x. Now to finish solving for x, this is where I use a logarithm. My logarithm will have a base of 1.05, and it will be of 125 over 44, and that's what equals x. Now I just got to type that in. And once I do that, I get 21.4 years. Now what that tells me is the year would be 2021. Remember, X is the number of years since 2000, the way I set it up. That wraps up the problem. So I talked earlier in this lesson about the compounding interest formula. Now if the interest compounds continually, this is the formula you've got to use. Principal times Euler's number raised to the rate times time. I'll show you this first problem. Determine the balance in an account with an initial investment of $5,000. They're giving us the principal there. times e to the rate is 3%, so I'm going to use 0.03, and it's going to stay in there for 4 years, it says. Now all I got to do is just type that in my calculator. Remember that e can be found on the ln key beside the 4 by hitting second e to the x. And what I'm going to get is $5,637.48. Remember, with money, we always round to the nearest penny. Alright, that wraps that problem up. Now I'm doing example 3. It's based off the same information from example 2. It says, when will the balance of the previous problem reach $11,200? So what you would do is actually be giving the amount is $11,200. We're going to be missing the time. Time is what we're solving for in this situation. So $11,200 equals, it's still $5,000 principal times Euler's number raised to the rate is still 0.03 t. Now I've got to solve for t. First thing I would do is actually divide by 5,000 on both sides. And I get 2.24 over here on the left equals e to the 0.03 t. This is where I'm going to use a logarithm. Since my logarithm would have a base of e, I'm actually going to use natural log on both sides. To finish solving for time, all I got to do is just divide by 0.03. So time would equal natural log of 2.24, close the natural log, divided by 0.03, and we're ready to type it in. And I get about 26.9 years. Sometimes the question won't give you actual amounts. It'll just want to know when the account is going to double in value. To do that, this problem is again compounding continuously. It does tell us that the rate is 7%. So I'll go ahead and put 0.07 in for that. Now, even though it doesn't give us A and P, it's wanting us to give time, we can actually know that if I were to divide by P right here, I would actually get a 2 on the left-hand side. The reason is it said it wants to know when the account will be doubled in value. So the amount in the account will be double what the principal would be. So no matter what P is, when I divide it out, it would be a 2 because we're doubling the value. Now all I would do is take the natural log on both sides, and I'd have natural log of 2 equals 0.07t, and I just got to divide by the 0.07. So natural log of 2 divided by 0.07. Once I type this in my calculator, I'll have my answer. I get an answer that is about 9.9 years. Now time to talk about modeling continuous growth or decay. And what you're going to do here is use this formula, which is the same thing we were just using, k being your rate of continuous growth or decay. Sometimes the k will be positive, as we've seen on the last few problems. On these next two problems, the k will actually end up being negative because we're going to have continuous decay happening with our population. And we're going to be talking about half-life on these problems. Okay, so it says the half-life of sodium-22 is 2.6 years. We're going to determine the value of k and the equation of decay for sodium-22. All right, so writing down the equation that I just had on the previous screen, I know that k is going to end up being negative because it is decaying. Only half of it's present. Speaking of which, since only half of it will be present after 2.6 years, I'm going to go ahead and put the 2.6 in for time. Also, I would know that if I were to divide both sides by the a value, this is going to be a ratio of 1/2 because it's half-life. There's only half as much of it now, y, as there was previously a. So if a was 1, y would be 1/2. So 1/2 divided by 1 is 1/2. So I'm going to write that 1/2 over here. Now to figure out what k is, I will simply take the natural log on both sides. So natural log of 1/2 equals 2.6k, and divide by 2.6. So natural log of 1/2 and divide it by 2.6. And I'll write that out what I was saying just now. K ends up being approximately, it's a negative value, negative 0.2666. All right, so there's my K value. I'm just going to the nearest 10,000th there. What I'd like for you to now do is make the equation according to the problem. So that was my value of K, that's half the problem. Now the equation is going to be y equals a times e to the negative 0.2666 t. All right, because this is our constant rate of decay. We don't know our time, we don't know the initial amount, but this equation will get used on the next example. Okay, so now we're looking at some sodium-22 that was on a meteorite. Geologist figures out that there's only 10% as much of it as there was originally. So I could actually go ahead and put 10% in here of 100% as my Y and my A. Or you could have used 0.1 and 1 instead, or just 0.1 over here because the 1 would cancel. Anyways, the ratio is what's important there. So whenever I do mine and divide by 100, whatever values you use, if you're using something that's 10% of the other, you're going to get 0.1 on the left-hand side. Now what I'll do is, again, I'm solving for t now, so I'm going to again use the natural logarithm. And now what that k value does is it's just going to divide over. So the t will equal the natural log of 0.1 divided by negative 0.2666, and now I'll just type that in my calculator. And I get about 8.6 years. All right, that wraps up the day. Let me know if you have any questions.